which way you do it. All I did was really a little simplifying it, as I'm looking at the slashes, okay? That's all I look at. I don't even look at the IP address. When I say /22, I make sure that this is exactly like the address down here, because it has to match. You with me? I want to make sure that this other 10 is the same. Why? Because I know that they have 16 bits in common, right? Now I'm looking at the third octet, and the destination that I want to go to is an 11. Well, the 11 needs to be in there. So then I look down here and go, well, then it must be in network 8. Because as long as I have a network 8/22, I know that 11 lives there on that network. So how I look at it, in other words, if I write the IP or I write, it doesn't matter. I want you to be able to sort of think like I am thinking right now. So what I'm thinking is, I don't look at anything else but the CIDR. CIDR of 24 means match, match, match. Because they're all ones as when I have a 24. Give me the first route that I have in the routing table. Okay, give me the IP. 10, 10, 0, 0. /20, is that what we have? Why wouldn't this be right? Because I have a /20, so I have 10, 10, right? That's 16. Over here I have 0 to 15. Because I have a /20. And then I have 0 to 255. Well, let's take a look here. Is 11 part of this? Yes, it is. But then so is 0 and all the way to 15 and 0 to 255. Okay? So yes, I could. No, you guys didn't give me the 10, 10, 0. The next hop is 12. So that will work as well. But because of the fact that I have to use the longest match, meaning here I match with 20. So that is less than the 22, and it is possible that my address is not in there, or my network doesn't live on there. So if I didn't have /22, then yes, I would forward it to this. Because am I on here? Yes. What's the second address? Go ahead, 10 dot. Okay, so what do I have here? /21, I have 10, that's 8, 10, that is 16, 21, that means I have 5, right? And that is a 0 to what? 0 to 7. Well, this one won't work, correct? Well, they would work, though, if I'm in the next one. So it is 8 to what? To 15. So I would be here. But compared to then the direct route that I have as a /22, being the longest match, I choose that one. I'm in all of those, but I have to use the longest match. And why do I have to use the longest match? Because that means that, hey, if you have combined things, the one with the longest match is summarize my route. Because I have more network bits in common with that network. Is there another example we could do? Okay. Pardon? Okay. Which output interface will packet for 10.10.192.10 use? Let's do number 2. which output interface based on the routing table shown in the figure, which figure? This? All right. Packet arriving from the directly attached host 10, 10, 11, 1 for forwarding. Assume longest match is used. 11, 1. Pardon? Slash 15, why? Okay, so let's look at 64 slash 18. Where is the host boundary? $11 is what I'm looking at in the third octet, right? Okay, so 64 would have 11 in it? Would it? Take a look. What is it? 10, 10, 64, 0? And it's a slash 18? Alright, so what do I have, folks? First two octets, I don't worry about, right? Because that's 8 and 8. So, when I have a slash 18, what does that mean? Okay, 2 on bits, so it's 0 to 63, and 64 to 127. Do I have this route, dot 0? If I don't have that route, can I get there? No. So let's take a look. I want to go to 11, so I have to use slash 16. Because if you go to the last one of slash 18, once again, 128, you don't have that first one in there. Because you want to go to 11. And 11 is not there. 11 is only in the first one. So longest match or not, that won't be a match at all. Okay? Let's do number 3. Which output interface will... I don't have 0... I don't have 10, 10, 0, 0 slash 18. If I had, then that would be the right answer. But I don't have that in my table. So the next one. Which output interface will packet 4, 10, 10, 192, 10 use? 192. Does everybody understand it? Now you're not doing subnetting, you're doing supernetting. So you look at it to find out, and really the long way of doing the same thing would be to write out all of those addresses and do ANDing. But you should be able to see it. Should be able to see it, right? And that's what I wanted to do. I wanted to write down the slashes, so the minute you see this, you divide it by what? What am I doing? I'm dividing 22 by? Am I asking the question correctly? By 8, right? Because it's 8 times 8 times, it's 8 times 4 that I get 32. Therefore, I have to find my answer in 8s. So that's when you see me always go 8, 8, 16. And then I go, okay, well, if that's 16 and 22, that's 6 bits on. That's how I find my answers. So you don't have the time to always take things to zeros and ones. Good luck, because it will take you a lot longer, especially when you take your CCNA exam. Do we have any other questions about the chapter? Sorry, but he took my book, so it's your all's fault. Yeah, you did, but it brought it back in the wrong place, man. Can I say? So row 2. Explain to me what a loopback is. So it's not a device, right? It's a virtual or logical interface that I create. Excellent. All right. I create a logical interface so that I connect. And why would I use a logical interface, row 3? Okay. If you don't want to connect anything to it for troubleshooting. Any other reasons, row 4? So a logical interface is used for troubleshooting. And another reason for it. Do we have another reason for it? Think about OSPF. Interface is used in the election process because it's always on and on. Okay? Remember, you didn't do a no shut when you added a logical interface. It is always on by default. So be very careful because then it will take part in the election process. All right. Now, Chapter 13 was also assigned for last week. And what's Chapter 13 about? System is all routers under one administration. SIU is an autonomous system because all of its routers are in one autonomous system. Walmart, an autonomous system. Deerberg's, an autonomous system. So the reason it's important that we know what an autonomous system is that I use interior gateway protocols, okay? Interior gateway protocols, such as RIP being the distance vector and then OSPF being the link state. I use those routing protocols inside my autonomous system. When I want two autonomous systems to communicate, I use a exterior gateway protocol, an EGP. Does that make sense to everyone? So that's how I communicate between autonomous systems. Yesterday we also looked at OSPF and configured OSPF. Give me some differences between distance vector RIP and OSPF being a link state. What are some differences? Yes? So we don't have the periodic updates. When does OSPF update then? Very good. When I have a topology change. What else do we know to be different with OSPF? At the beginning, right? At the beginning, it is CPU intensive because of the fact that each router will learn the topology, and each router will have the LSA. But once I've converged, in other words, once all the routers in my autonomous system have the same knowledge of the network, then it's no longer CPU intensive. Why? Because I don't do the periodic update. Because once it is configured and it's working, it is not as CPU intensive as it was. Good enough? All right. So that was sort of a review again, and I'm going to come back, obviously, and hit Chapter 13 again, first as a lecture format, and then ask you questions. Good? Connecting two autonomous systems, there are external gateway protocols, EGPs, and the protocol widely used out there is BGP, Border Gateway Protocol. Okay? So now, the new labs that you have in front of you are ACLs. And let's talk about ACLs. So when we configure ACL, what are they? Well, let's go ahead and talk about that first. Access control lists are ways of filtering your traffic. Okay? Access control lists are ways of filtering your network traffic. What's important to note with access lists is that you have standard, extended, named ACLs. So let's take a look at a standard ACL. About 8 or 9 years ago, it was important that we said we have standard, extended, named IP ACLs, and then IPX. But basically, we know de facto IP is being used everywhere. So let's just make sure that we understand that right now, when I talk about ACLs and the various types of ACLs, I am talking about IP-based, okay? Not going into any other protocols. So for standard ACLs, in order for us to distinguish them, we have a naming standard. So for standard IP, we have reserved 1